All right, hello everyone. Welcome to this workshop on Arbitrum Stylus. So we are going to talk today about what is Arbitrum Stylus, and we are going to see an example of something that can be achieved with the stylus that is not easily doable in Solidity or with the EVM, right? So first of all, my name is Jose Franco. I'm a blockchain engineer at Offchain Labs. Here are my Twitter and Telegram handles. And Offchain Labs are the initial builders of Arbitrum 1 and Arbitrum Nova before they were transferred to the DAO. And we are also the developers of Stylus, the Orbit stack for creating new chains, Bold, Time Boost, and a whole lot of technologies that are available on Arbitrum chains. So this workshop is divided into two parts. The first one is a bit more product-oriented, so to speak. We're going to talk about what is Stylus for those who don't know what it is. And we're going to see an example of a small counter contract that is written in Rust. And then we are going to talk about the main problem that we want to talk about in this talk, the on-chain chess engine, okay? What is the challenge that we have to solve, and we're going to see an example implementation and a demo if we have time. All right, so what is a Stylus? A Stylus is an upgrade to the traditional smart contract development environment available on EVM chains. What that means? It means that if you want to write a smart contract in an EVM chain, you usually do it in Solidity or in Viper, but those are like the two options that you have, right? So Arbitrum Stylus allows you to write smart contracts in other languages, like Rust, C, C++, and many more languages. And this is thanks to a new virtual machine that is a Wasm virtual machine, executes Wasm programs, and lives alongside the EVM, and it's fully interoperable with each other. That means that Solidity contracts can call Stylus contracts and the other way around. Stylus gives us many benefits. And some of them are like we can now access a broader development ecosystem and onboard Web2 developers. That means that, for example, for a Rust developer or a C++ developer, if they wanted to write a smart contract or do something on the blockchain, they had to learn a new language. They had to learn Solidity to do that. Well, that's not the case anymore. They can use the language they know and write smart contracts as powerful or even sometimes more powerful than Solidity contracts. You have access also to general purpose language tooling that like the crates repository if you're writing in Rust. And you can access new use cases like advanced cryptography, generative art, and complex computation like the example that we're going to see today here. What tools do we have available for Stylus? First of all is we have a Rust SDK. This is the SDK that we've put more effort in, besides the actual virtual machine, of course. So we have the Rust SDK. We have proof of concept SDKs for C and C++, but actually you don't need these SDKs if you want to write a contract. You can use any other language that compiles down to Wasm and write a contract. We have examples also of contracts written in assembly script, in SIG, and I'm sure there are other contracts written in other languages. And of course, the Stylus is available in all Arbitrum chains, and new Orbit chains that are created today, they have Stylus available at the beginning. Some resources that we have if you want to start coding in Stylus. The first one is the quick start. Is a page that we have in the portal documentation, in the documentation portal. It shows you how to set up your environment to start writing contracts in Rust. And then we have Stylus by example, which mimics Solidity by example, and it shows you like a lot of code snippets and examples of things you can do with the SDK. The documentation that we have today is mainly focused on Rust smart contracts, but we also have documentation in the portal for other languages. Okay, and let me show you just a small example of a contract that is written in Rust, so you know more or less what it looks like. If you are familiar with Rust, you know that you can use a tool like Cargo, for example, and you just do like Cargo new whatever, and you create a new project. So in this case, you can do the same. You just use cargo to create the project. And what we are seeing here is a snippet of the lib file that is created when you start a library project, right? So we have here that we are importing the SDK, and then we have the stall storage macro. This starts to get a bit more technical for those who are not technical focused. So we have the stall storage macro where we define the storage of our contract. In this case, we only have like one storage variable, which is a UN256, it's a number. And that's inside a public struct that's called counter, and this is what we are going to call our contract, okay? So once we have defined our storage, we can start writing the functions to access and manipulate that storage, right? In this case, we have 3 public functions that goes inside an impl block for the same struct that we defined earlier. We have 3 functions here, number, set number, and mult number, and it just manipulates the storage variable that we have, or just return it like in the first case. Okay, this, as you can see, is pure Rust. In here, we are not using Solidity, and something that I didn't mention before is that this storage variable, the syntax that we are using here is Solidity, but you can use Rust syntax also if you want. And finally, we have testing. When you write a Rust program, you usually put the unit test inside the same file where the functionality exists. Well, the same goes for Stylus contracts. So you just put the unit test in the same file and just verify that all the functionality that is within that library or within that contract works as expected. So let's move to the second part, which is a bit more interesting. Are there any chess players here, by the way? Any chess players? No one? One? Okay, so we have one. So he'll know what I'm talking about. All right, so when we want to put, when we want to work on a chess engine, just the chess engine without putting it on chain, we have a complex problem to solve. So for those who don't know, chess has different types of pieces, and each piece moves in a certain way. Like, for example, we have the knight that hops over other pieces and moves in an L-shaped movement. We have the pawn who moves just one square forward, unless it is the first move, then it can move twice, or if it is capturing a piece, it can move diagonally. So we have like a lot of different movements that the different pieces can do, and we have to somehow verify that every time a piece moves, it's doing it in a legal way, so to speak. It is a legal move, right? That means that, for example, I don't know, a pawn is not moving like 3 squares forward, or if your king is in check, you cannot like move any other piece. You have to defend your king, stuff like that, right? That's a lot of computation that you have to done in your contract, in your program. Now, if you want to put that on chain, you have a limitation there, because if you are doing a lot of computation, that costs a lot of gas. And when you're using, for example, Solidity, which is not as performant as Wasm for this kind of computation, you run into a problem that you might reach the limit of the gas that you can spend, and that doesn't work. So the problem that we've seen is that I haven't seen any Solidity complete chess engine. That means a chess engine that is completely written in Solidity. I've seen a few things, but they are never complete and are usually for this because of this. And with Wasm, we can do that because let's say that the engine that runs Wasm programs is more prepared for this kind of computation. Okay. I'm not going to go deep into this because this is getting very technical. But in the end, this is like a smart solution to solve the problem of how you calculate whether a move is legal or not. Okay. So in this case, if you want to write a chess engine, you can just write everything yourself and do all the calculations, write all the contracts, all the code yourself, or you can use a library from someone who has already solved this problem. And this is what we're going to try to do here. There are certain things that you have to keep in mind when you are choosing a library to write for your contract. One of them is that you shouldn't use the standard library that comes with Rust because it is too big and you are going to reach the limits, the contract limit of the chain. There cannot be parallelization, no randomization either because we are on a deterministic environment, deterministic and sequential environment, which is the blockchain. And for now, you cannot use any floats, but we're trying to work around that limitation. Okay, so it turns out that we have a solution. We have a crate that exists in crates.io that actually implements a full chess engine that is written in Rust. Okay, and we have integrated this engine inside a smart contract, and this is a complete engine. It takes everything into account, even I don't know, if you are castling, if you are doing complex movements of chess, everything that you can imagine, it can support it. And we are going to see a demo now. I'm going to show you a bit of code. For those who are not engineers, sorry about that, but I'll try to make it friendly for you guys. Okay, so here I have my environment, and can you see the code well? Yeah. Okay, so this is a cargo project actually, and this is the lib file that comes when you write a library. We are importing here the chess engine, the Stylus SDK. We have a few constants. I didn't explain it before, but for those of you who want a bit more technical, in the end you are putting all the information in a 256-bit integer. You have 64 squares, and you have like 3 bits for the piece and 1 bit for the color, and you multiply all of that, and you have like 256 bits. So in the end, you're putting all the information inside one storage variable, right? And this is just some constants to just facilitate what we are reading from that storage, right? We have our storage layout here. Our contract is called Stylus test. We have total games, pending games, and the games mapping. Each game has this information: player 1, player 2, what the status it is in, if it is still playing, if you can, I don't know, if it is finished because someone won or something like that. What color is it? What color has to move now? And who is the victor if the game has finished, right? And then we have the board state. As I said before, everything fits into a 256-bit, and we save that in the board state. Then we have a few public functions that I'm not going to go very deep into them, but just to show you that we have this function, play move. You just say, okay, this is the game that we want to move in. You go from this row to this column to this row and to this column, and the contract calls the play move function from the crate that we imported and just verifies if it is a legal move or not. Okay. So I want to show you now just what it looks like. I'm going to run the demo for you guys. So first of all, I'm going to deploy the contract. I have a local chain that is running that I'm going to show you now. So the local chain is just running here. Okay, so in here, we just deploy the contract at this address. You'll notice that the contract is a bit above the size limit of chains, which is 24 kilobytes. This is 25 kilobytes. In this case, it's fine because I'm running a local chain. But this is because we are using something to display the board, and we are going to see that now, to display the board in the node logs, which is something that you are not going to do in production. If you remove those functions, that's actually the feature that we have here. If you remove that feature, the contract size goes down to 21 kilobytes, and that fits perfectly on a chain, right? So we are going to take this contract. I'm going to put it here. Don't worry about this private key because it's all over our documentation, so nobody's going to steal any funds. And then we are going to, I think this was get total. Yeah, we're going to join the game here. You are going to join twice because we need 2 players. And then this is what I want to show you, which is this is going to show the board in our node logs. Of course, as I said, you will have on a production environment, you will have a user interface to show this board, but in this case, just for this demo, we chose to do this here. And then we're going to run a set of moves here, which is we just placed the scholar's mate. For those of you who are Spanish and familiar with chess, this is the mate del pastor. So this has now make all those moves, and in the end it says, okay, the game status is finished. Black is the victor because black is the player who moved, who did the mate, actually. And we see that all the movements are now recorded in the node logs, right? Yeah, so that's it. If you can change to the presentation now, can you change to the presentation? Yeah, don't worry. Okay, so that's what I wanted to show you. If you want to play with this demo, with this Stylus chess, you have the repository here available. You can also scan the QR code and it will take you there. And again, if you have any doubt or you want to talk about Stylus, we have a Telegram channel. You can go to our Discord. We have there the documentation portal as well. And yeah, and that's it. Thank you very much. Sorry, I'll leave this on. Thank you very much, and hope you enjoy it. Thank you.